Hi there! I'm here to talk about non-caloric and low-caloric sweeteners. These are non-sugar compounds, either natural or synthetic, that impart a sweet flavor but provide no or negligible nutritional value. First, we have polyols. These are polyhydroxyl alcohols that are less sweet than sucrose but provide texture and bulk and retain moisture in foods. These in dry form have a cooling effect, so are often used in gums. Next we have cyclamate. This was approved in the U.S. in 1949, but was then banned in 1969 due to carcinogens found in lab rats. This is 30 to 40 times sweeter than sucrose, and it has no off flavor and is heat stable. Another sweetener is saccharin. This is 300 times sweeter than sucrose. It does have a bitter or metallic aftertaste and also must have a health warning on the label. Next is aspartame. This is a dipeptide, so it is caloric, but it is 200 times sweeter than sucrose, so provides negligible caloric value. There is no off flavor and was approved in the U.S. in 1981. This is unstable in acid or heat and can provide an off flavor during storage. This also contains phenylalanine, which is required to be on the label. Asulfitane K was approved in the U.S. in 1988 after being discovered in Germany. It does have a bitter or metallic taste in high concentrations, but is 200 times sweeter than sucrose. This is heat and acid stable and provides no calories. Sucralose is 600 times sweeter than sucrose. It is stable at high temperatures and pH, so is used often in soft drinks. Another sweetener is allantoin. This is an amino acid and so is 2,000 times sweeter than sucrose. It is thermostable and soluble in water, but during long storage in acidic conditions can lead to off flavors. This has been pending approval in the U.S. since 1986. Another sweetener is neotame. This has 2 amino acids and is 7,000 to 13,000 times sweeter than sucrose. It is thermostable but can produce off flavors after long storage in acidic conditions, and this has not been approved in the U.S. Another sweetener is stevia. This is found in the South American stevia plant and is 300 times sweeter than sucrose. It does have bitter or off flavors at higher concentrations. Some other sweeteners include beta-substituted beta-amino acids, which can be 20,000 times sweeter than sucrose. Also, tri-substituted guanidines can be 170,000 times sweeter than sucrose. Glycosine, which is found in licorice root, can be 50 to 100 times sweeter than sucrose. It is approved as a flavor and surfactant in the U.S., but not as a sweetener. Neosporin dihydrochaperone is 1,500 to 2,000 times sweeter than sucrose. This is found in the citrus fruit and has a slow onset and lingering taste, but has not been approved in the U.S. Next is thametins 1 and 2. These are from the tropical African fruit called catimfe. It is an alkaline protein, 1,600 to 2,000 times sweeter than sucrose. It is approved as a flavor enhancer in the U.S., but not a sweetener. This also has a licorice-like taste. Manelin is from the serendipity berry, which is a protein and is 3,000 times sweeter than sucrose. This is not heat or acid stable and is destroyed by boiling. Miraculin is from the miracle fruit. It is a glycoprotein and changes flavors from sour to sweet, so it would make a lemon taste sweet. This has a low heat tolerance and is acid stable. Not acid stable, but induced by citric acid can be 400,000 times sweeter than sucrose. The flavor of this also lasts 24 hours, so I hope you like sweetness. That's all I have for you today. Good luck on your finals!